So, yeah, you've seen that this effective population size is getting quite some answers and questions, and what I want to do here is look at, take the advantage of the monitoring plots we have in Slovenia and show you how the sampling design affected these estimates of effective population size. And by now you know that the effective population size is the headline indicator within Convention of Biological Diversity for reporting on the proportion of populations within species with an effective population size higher than 500. And this higher than 500 makes a lot of sense because effective population size that is higher than that number would have enough of genetic variance for adaptation in a long term. But we've been talking about it, but nobody actually told the definition. So what is effective population size? It is the size of an idealized Wright-Fisher population that has the same value of a given genetic property, and that property can be anything. It can be inbreeding, additive variance, it can be linkage disequilibrium, heterozygosity, and the headline indicator doesn't tell us exactly which one we should look at, so I guess we can report on any of these ones. And the other thing, that I want to point out is that these genetic properties would be determined at processes at different scales, so the additive variance and inbreeding on regional scales, while, for example, linkage disequilibrium would be determined at a much smaller, like local scales of the neighborhood size. But as Santi said, effective population size is a beautiful concept, and I think the indicator is really good personally for endangered populations with small sample sizes, and it tells us a lot, despite all these caveats. So if we have higher inbreeding or drift, then genetic diversity is being lost, which means that we have less efficient natural selection. And in terms of the indicator, what we are interested in is the contemporary effective population size, not the historic one. And even when we are talking about contemporary effective population size, what we are actually getting when we are estimating is not the current adult trees, if we are looking at the trees, but actually it's the parents of these trees. So it goes a little bit back in generations. And typically it would be smaller than census size, but I guess that's a very basic information. So how can we estimate it? We can estimate it with pedigrees. Unfortunately, that doesn't really work well in forest trees, but we can do it also with reproductive parameters and with genetic methods. And I will be using both of those approaches, looking at our different sampling designs. So let's go straight to the empirical part of the study. So as I said, we have two monitoring plots in Slovenia. One is for beech and the second one is for silver fir. And these are located in stands that are genetic conservation units. And they are embedded in a larger population. So what I will be using is for the gene conservation unit and stand, this will be intermixed in my talk, while a population I refer to, like what you see is, for example, the red area here. So there are no barriers to gene flow within here. All the populations that we have tested belong to the same gene pool. So that would be considered a population, and the area is quite larger. Now, our gene conservation unit for beech is 100 hectares large. For silver fir, our gene conservation unit is smaller, it's 17 hectares. And you will see that this kind of also influences the estimates. So, Fagus sylvatica. Here we had two sampling design. Now, design one was a single sampling point, and I'm stretching this single sampling point because actually I'm talking about 1 hectare, where we have genotyped all trees with a DBH of over 15 centimeters. There were 251 of these trees, and actually they were, except for 4, they were all flowering in different years. Now on the same plot we had 4 regeneration centers among many of them, and we have sampled 200 seedlings in those centers. Design 2 was spread over the entire gene conservation unit, so over the entire 100 hectares, and it consisted of 5 points Each of those points were concentric circles where trees were at least 30 meters apart from each other. And again, we sampled regeneration in this, next to these adult trees. So also the regeneration was spread over the entire 100 hectares. Now, when we look at the results, and these are the results obtained with the NE estimator based on 16 nuclear microsatellites, and here they are reported for the one sample estimate. And what you can see is that the design one, so the single point, which would be typical for kind of population genetic study, maybe a little bit larger than 1 hectare, really underestimates the effective population size of what we would expect. Basically, it's giving us something in the range of the neighborhood, or actually all adult trees, when we are looking at all the trees. Now, when we look at design 2, which covers the entire 100 hectares, the numbers are much higher. And they are really similar to what we would expect in terms of effective population size on 100 hectares. But this is still an underestimate considering the entire area I showed you as a population. When we look at 2 sample designs, so temporal estimate, putting the adults and the regeneration in the same calculation, we get values similar to what I showed you for single sample estimates. And the minus here refers to the infinite estimate. So for the design to the 100 hectare plot. But there was another way that we used to calculate the effective population size, and this is based on reproductive variance. Here we use the mixed effects mating model, and this is a model that estimates relative fecundity and dispersal kernel together in Bayesian framework. But what it outputs is also the inverse of a ratio between NE and NC. And for our population, here it was in the range of 0.2, so 0.195. When we compare all these results, and we look at the census size at the stand or at the GCU level, we know from the forest inventory, which we use to estimate the census size, that we have 25 adult trees in the area of this 100 hectares. A ratio of 0.2 gave us effective population size of 5,000. Now the sampling spread over the entire GCU was in the same range, but the sampling that would be typical for population genetic studies was vastly underestimating this, the effective population size. Now if we would want estimate for the entire population, clearly we wouldn't be able to trust the methods or the results based on linkage disequilibrium because they are much smaller of what we would get using a ratio which would give us an effective population size in the range of 1 million. And now for the second study, which is Abies alba. Here the sampling, we only were able to test the sampling design 1, so single sampling point, and here the single is stretched even further because actually we are covering 2.3 hectares, but again we have 250 adult trees and 200 seedlings. And the estimates are in the same range as they were for beech for the design 1, so much smaller than the threshold value of 500 for the effective population size. Here we used 14 nuclear microsatellites. The temporal method gives us the same kind of results, and the estimation based on reproductive variance is also very similar to what we got for beech, 0.2. So if we compare the results of the estimates to the census size and using the ratio, well, we can again see that what we got with the sampling is basically an effective population size for the sampled area, not for the entire population, which would be in the range of 500,000. Again, what we got was well below 500. So if we can take something out, and I know this is very limited, but there are also some publications that have done similar things. And what seems to be the case is that effective population size depends on how we sample and what kind of samples we have. So if we have locally restricted samples, we will underestimate the effective population size. Even if we have them widespread across the entire gene conservation unit, that would be a good estimate for the gene conservation unit, but it would still be still be too small for the entire population. So, I mean, personally, I would be very skeptical of using molecular methods to estimate effective population size based on what we usually do when we sample for population genetic studies. So, that was it.
Thank you so much, Marjana. Because after all the theory that we heard from Ivan, now we have actual data to discuss. So, any questions for Marjana for this presentation? How about the Zoom? Well, I'll start.
Oh, can you hear me now?
Kostya?
Can you hear me now?
Yes, we can.
Oh, great. Thank you. I use this opportunity to check my microphone. So I'm a victim of Parkinson law. If something can go wrong, it will go wrong. But sorry, Marjana, thank you for nice presentation. Very interesting. It's very important for conservation genetics to estimate effective population size. What do you think for species like you study? What would be a reasonable effective population size to maintain in conservation programs or recreation programs or restoration programs? For conifers, it could be different. It depends on species. But for species that you study, what do you think would be a reasonable effective population size in forest restoration programs, let's say?
Forest restoration programs? Oh, as large as possible, huh? Can you hear me? Okay, yeah.
But we're limited by budget, so it cannot be as large as possible.
Yeah, I mean, if what the theory tells us is that 500 should be okay, I've read papers that say that that's slightly underestimating it. So, and some simulations show us that 1,000 would be better, more on the safe side. So I think, yeah, that, but yeah, the higher the better, huh? But you've seen that using the ratio, what we get, it's much higher for continuous population. So I don't know, you were probably asking what we should maintain when we have seedlings, or is that what your question was? Before we plant them, that we should check the seedlings that they have a high enough effective population size. Yeah.
Yeah, that's also true for seedling material. Or if you're talking about, restoration, ecological restoration, yes.
Yeah, I would say that it should be at least 500, right? Like the indicator is.
Okay, thank you.
Yeah. If
Great.
you want
Did I earn a C-shot now? Thank you, sorry.
Yeah, so Barbara and then Ivan.
Hi, thanks for the opportunity and thanks for the talk, Marjana. Since you are skeptical to use NA based on molecular markers, because it depends so much on the sampling scheme, what about if you follow in time a population or a generation and you do like you would do the analysis on different time points? Do you think that would be a measure that can be useful?
Well, in absolute terms, I think it would be still under 500, with the normal sampling. But what we could use maybe is that it doesn't go down. But then again, it would again be relevant for the area that we have sampled. So that's, I think here we run into problems. So if you want to get a really good absolute value of the effective population size, we have to go across a large area, across the entire population, and hope that we don't have identity by IBD structure, because that would also skew the estimates. So, but yeah, maybe we could solve it by looking at the trend in the effective population size. But unfortunately, that's not the headline indicator. Yeah.
Ivan?
Thank you, Marjana. Great talk. Somehow, I mean, this and NE is like FST is part of the legacy of Sue Wright, who really love to make jokes to the next generations of population geneticists. And I was wondering, and even if you had the perfect way of measuring NE, like you count the number of descendants and you have a direct estimation of, and blah, blah. The problem is still that the guy conceived it for closed populations with perfectly random mating, and we don't have that.
No, we
don't.
And we will never have it. Yeah, I mean, for practical reasons, I would say that, well, if you have to estimate it somewhere, do it in an isolated population when you suspect there is a problem. And in terms of forestry, I mean, we know that there is a problem when there should be regeneration, but we don't see it. So, yeah, and then I think it would pay off to have these values, but otherwise, if you want to do it properly, it's probably too expensive, and too time-consuming. Yeah.
Great, I think, yeah, Berthold.
Thank you. You were very skeptical. I'm not so much really, because maybe because what you are trying to conserve in one of these genetic conservation units of the EvolTree network is actually the unit. So if your NE estimates tend to be low, you could have larger units, couldn't you?
Yeah,
and,
sure.
And the other thing is, if everybody would sample and calculate NE in the same way for this one network, it would give you good relative values, wouldn't it? And it would tell you probably where the problem is, if there is any.
Yeah, no, you are absolutely right. That was not my point. My point was the indicator and the threshold value of 500. And if we use what we normally use in population genetics, we would get underestimates of effective population size. And my point, I mean, I wanted to warn ourselves that maybe we should be a little bit thoughtful before we do something like that. But I agree with you in terms of the European network. There are things that we could do that would give us relevant information for our work. Yeah.
Are there any other questions from the floor? Yes, please. The micro. You want to ask a question, right? Yeah. How about the mic? Thanks. And then we have from the Zoom.
Oh, thank you. Thank you for your presentation. I was just wondering whether you tried to make calculations with a different number of markers, and maybe to see if there's some drop in the NE value below some marker number.
No, we used 16 for the beech and we used 14 for the silver fir. But I mean, really 14 and 16 is not that large of a number that you would be able to drop many. So this would be kind of normal, right? But we dropped the number of trees in the calculations, and that even decreased the effective population size. So 250 trees would not be a standard what you would do, but you would do 25, 30 trees.
Yeah, thank you.
Sandy?
Yeah, just to say that in another case study in my campaign, we have been testing a different number of markers and kind of markers, comparing macro satellites with SNPs and different SNP sets, and also different sample sizes. And it's always the same, it doesn't change. The only thing is when you have a bigger sample size, you have less variance. But the estimate is fixed, and normally it's always, using these conventional methods, it's always below 500. And we are talking of populations with millions of twins, like all the Maitampine in southwestern France, that is 1 million hectares of continuous forest, you get 300 effective population size. But then what it seems to work, like Marjana was showing, is when you do estimates based on reproductive success. But that means having another kind of study when you have, 500 adults, natural regeneration, everything genotype, and then you build a mapping system model that can estimate the ratios directly, and then you can apply these ratios on the census size. And then it seems to work, but it's so much work that makes you wonder if really, if we really, like a community, we want to spend our lives doing this kind of studies. So.
Yep. In fact, there is a question by Felix on the Zoom.
Yeah, he says that it's now obsolete because he was asking about
okay.
microcycle.
Yeah, so that's what, probably this answers that as well. Is there any other question for Marjana? Well, if not, thank you so much, Marjana.
Okay, thank you, Phil.